2.2 is on quadratic functions. The first thing that we're going to look at is what's called the general form, which is f of x equals ax squared plus bx plus c. Now typically we think of a quadratic function as being one that has the highest exponent of a 2, which we have here, and the graph of this function is always a parabola. Okay, a parabola is a curved shape that has symmetry. This would be an example of a graph that's a parabola. Like I said, it's either going to be a curved up shape or it could be a downward curve. With a parabola, there are some terms that you need to be familiar with. The first one is the vertex. The vertex for this parabola that I have graphed here would be the point 0, 0. Okay? The vertex will be either the minimum point if the parabola is open upward, or it will be the maximum point if the parabola were open down. The axis of symmetry is a vertical line that will pass through the vertex. So it's for this parabola would actually be the y-axis. So because it is a vertical line, the axis of symmetry is always x equal to a number. It's always going to be equal to the x value of the vertex. So here my axis of symmetry would be x equals 0. And then I've talked about minimum and maximum. Okay, if we do have a graph of a parabola that's opening upward, then our vertex will be the minimum. Okay, so we would say the minimum is 0 and it occurs at x is equal to 0 for this graph that we have here. Now there's a lot of things you can tell about the graph if you know the equation to the graph. So we say that our leading term here, which is ax squared, if a is greater than 0, which means that it's positive, that lets me know that my graph will open upward. Okay, like the graph that I have here. If I have a parabola that's open downward, my vertex would be the maximum point, and we'll just say for my graph that would be this point 0, 4. That would be at the maximum. The maximum would be 4, and it would occur at x is equal to 0. And so for this graph, the a value, the leading coefficient in my equation, would actually be less than 0. So when you're looking at the equation, you can tell just by that leading coefficient whether your parabola is going to open upward or whether it's going to open downward. And then here also we said we have our vertex, that the axis of symmetry would still be the y-axis here, and it would be the line x is equal to 0 again. Okay, so just make sure that you're familiar with the terminology. You'll have some questions in the homework that may ask you for different parts of the graph. Okay, let's look at the next example. It says to graph the function f of x is equal to x squared. Okay, if we graph this, this is a parabola. A is the coefficient of the squared term, so that's an understood 1. That means that my parabola would open upward. If we want to get just some exact points, we could do this by using the XY chart. If I plugged in, let's say, a 0 for x, then if I plug that in here, that means my function value would also be 0. If I plug in a 2 for x, 2 squared, my function value would be 4. And let's say we plug in a negative 2. Well, negative 2 squared would also be 4. Okay, that gives us 3 points on the graph. 0, 0, 2, 4, negative 2, 4. And so we can kind of see what our shape would be for this parabola. So my vertex would be the point 0, 0. My axis of symmetry would be x is equal to 0. And then we know that it opens upward again because of the leading term being a positive. Okay, so it says use this to graph g of x. And g of x is equal to x minus 4 squared plus 1. And so I want you to think about transformations. How does this equation change from the parent graph that we had? Okay, we've looked at transformations in chapter 1. We know that if a constant is being added to the function, like the plus 1, that would mean my original graph would go up 1. If we have a constant being added or subtracted to the x value, then that means for this problem, since it's a negative 4, it would move in the opposite direction, so to the right 4. So I could take my vertex, which I knew was 0, 0, and I would move that up 1, because I would have a vertical translation up 1, and to the right 4. And so that is where my new vertex would be for my new equation g of x. Now I could plug in some values again if I want to get the exact points, which you will have to do on the homework. You'll have to find one other point. So you may want to just find a value that you plug in. Let's say, since my vertex is here, if I plug in a 0, that would be negative 4 squared, which would be 16 plus 1. That's going to be 17. That's going to be way off my graph, but I'm just going to go ahead and sketch the curve. On paper, you wouldn't have to be so specific, but just for the homework, you would have to plug in a point to get another point. So this is the transformation, g of x, of the original function.